demonstrating farm digitalization. And to do so, I don't think is anybody better than the very coordinator of Codex, Professor Gianluca Brunori. The floor is yours. Thank you.
Thank you very much, Serafin. Welcome to all participants. I will briefly introduce some ideas that are behind this bootcamp. I start with the Codex overarching goals that is to improve the collective capacity to understand, assess, and foresee the full range of benefits and costs of farm digitalization, and also to build digital ecosystems that maximize the net benefits of digitalization. So on one side, we need to understand exactly how digitalization can bring added value to farming, to agriculture, and to overall society. But at the same time, we are studying how we create the conditions for having this capacity of creating added value. And on this regard, we have to start with, let's say, the object of study. The present state and present phase of digitalization is a phase where we have a large set of devices, and the characteristic of this phase of digitalization is the connection of all these devices together, that they exchange flows of information to produce goods and services. And from the combination of these components, goods and services emerges, but also innovation emerge. So, but this is not the only part of the story, because together with the connection of devices, we have the connection of the physical world, so plants, animals, and all the, let's say, physical components of the environment, but also the social component. So we need to see how this interaction between digital components, physical components, and social components change the shape of the organization of agriculture and the costs and benefits. So to do this, we have identified the 3 levels of analysis. So we start from the process that has to be observed at farm level. Then we have the digital ecosystem, which is already in our overarching goals. The digital ecosystem is the environment where the farming and the processes occur, so they can constrain and enable digitalization and the deployment of the effects of digitalization. And then we have a socio-ecological system in which the digital ecosystem interact, and so it produces effects on the environment and on the overall society. So we have several policy implications. For example, the question that we raised on our policy, let's say, analysis is: what are the digital technologies on which is worth investing public money? What is the return on public investments in digital technologies? In which areas of the system should public policy intervene? We today, as already Serafin said, we will address 3 areas of action of Codex. First of all, demonstration. Demonstration is very important for us because it's not just something that comes at the end of, let's say, a process of innovation, but it is really a moment of learning in the context. So not only having let's say, a ready technology to be assessed and to be demonstrated, but also a possibility for farmers to intervene in the process of development of the technology in the specific context, because we know that digitalization is very much context dependent. Then the second aspect is related to knowledge and innovation systems. And on this regard, we want to see how knowledge flows can be managed to orient digitalization towards social benefits. And on this regard, the role of intermediaries is very important. So not only farmers, but intermediaries of knowledge. And in the, let's say, in the evolving context, we see that there are a lot of different types of intermediaries of knowledge. And third aspect, the policy. We want to see to what extent policy can support transformation in the, let's say, idea of creating a sustainable digitalization. So these are the context of the three workshops. I would like to thank you for your participation and at the same time giving, let's say, and enjoy these seminars. Thank you, Serafin. Back to yours.
Thank you very much, Gianluca, for this presentation. And good morning, everyone. I'm Marinda Boaché and working in Codex as part of ADL. So now that we have a good introduction of what Codex stands for and what the different topics that the project is working on, we'll get back to the agenda with the first presentation from Dolinda Cavallo, who is the project manager at the European Network for Living Labs. And so she manages EU projects across agriculture, environment, and social inclusions. And today she will explain how to run successful Living Labs pilot and demo farms. Dolinda, the floor is yours.
Hello, everyone. Can you see the screen correctly?
Yes.
Yes. So hello, everyone. Thank you for the invitation. So my name is Dorinda Cavallo, and yes, I'm here to bring in some way our experience on living labs, what are the objectives on living labs, and how to ensure long-term impact. So first of all, I will give you some information on who we are. So ENOL is an international no-profit association of certified living labs. It was founded in 2006 under the Finnish European presidency. And our aim is to promote the living lab concept, to support the living labs establishment, and to ensure above all the sustainability of the living labs and their continuation in the long term. Our community gather more than 172 active members across 5 continents, and we have already certified more than 500 living labs. And we're also, of course, involved in several projects, European funded projects, and some of these you can see below, like Soil or Vitalize or GIL. The Living Labs concept was started already in the 90s, and it was mainly applied to the, let's say, topic of ICT or health. But in over the time, the Living Labs started to address different topics as urban, rural, but also the agriculture or soil or soil topic. And here you can see how our members, let's say, address the different topic in a transversal approach. Then we can see here what living labs are. It's always important to start from a specific definition that we apply, and in ENOL we apply, that defines living labs as open innovation ecosystems in real life environments based on a systematic user co-creation approach that integrates research innovation activities in communities, placing citizens at the center of innovation. So in this definition, we can see how living labs operate as intermediaries among different stakeholders specifically focusing on the quadruple helix engagement. So in a living labs, it is important that all the actors of the quadruple helix are actively involved in the living labs. So from the government or public sector, the industry or the business, the civil society, or the academia and university. So let's better understand what this definition means. We talk about open innovation ecosystems. So it means that innovation doesn't have to be only carried out among a specific group of researchers or a specific group of stakeholders, but it has to involve all the stakeholders of the quadruple helix. And it has to be user-driven innovation. So users has to be at the center of the innovation. It is essential that the living labs are placed in a real-life environment, because this can then avoid to have, let's say, a gap then when or a failure when then the innovation has to be carried out in the real-life environment. And so this is another, let's say, definition of how users should be at the center of the quadruple helix model. And they don't have to be, so the users are the actors, not the factor that then are involved just at the end of the innovation. So here is an example on what an agri-rural living labs looks like. We have, of course, the researchers and advisors, cultivation experts that carry out in some way the experiments and the tests. But of course, we need the new technology that is developed. But then we, of course, need the farmers who will have to be involved in all the steps that the living labs carries out. And then, of course, we have to involve the suppliers, retailers, and the customers that then would be the one buying the final product. And to make sure that these ecosystems work in a sustainable way, it is essential then that the living labs create a trustful environment, because it is essential that all the stakeholders continue to work and are willing to work and to contribute to the living labs for in the long term, not just for a specific project. And to do this, we have some essential building blocks that should be always taken in consideration in the living lab setting. So we mentioned already the active user involvement, and the user should be involved through co-creation. So co-creation should be at the basis of each living lab activities. The real life setting is, again, an important, an essential factor of the living labs. And living labs should include multi-method approach. So multi-method approach, meaning you don't have to follow only one approach, one methodology, but you have to be ready to also change and apply different type of methodology depending on the need. Orchestration, so it is essential that in the living lab, all the actors are engaged and work together, and then a multi-stakeholders participation, because it is essential that there is not one type of stakeholders involved, but all the stakeholders of the quadruple helix are involved. And so why the living labs approach work? But because the risk innovation, so in some way involving users from the beginning allows to in some way bridge the gap between research and market, and so a real life environment already allows to test in real life how the innovation can carry it out. And here you can see also all the other examples. And so one of the, let's say, main gaps that we see or main difficulties or challenges that we see when establishing a living lab is that sometimes living in the beginning, let's say, living labs, when they want to establish a living lab, they focus only on a project level, so focusing on one project only, and when the project ends, everybody continue in different ways. But this is not what a living lab is. A living lab should make sure that the stakeholders continue to work together in a long-term vision. And this is essential to ensure a long-term impact. And so for this, we follow this three-layer model. So the three-layer models explain how a living lab should be structured, where we have a micro level that are the specific activities that are implemented within the living lab. So where we involve where the users are involved and the specific individual activities are carried out. Then there is the meso level, and these are the project. Where, of course, depending on the activities, they may belong to a specific project. But then it is essential to think at macro level. So living labs should think at macro level. That is the level on when the different stakeholders are involved in the public-private people partnership, the quadruple helix. But in this macro level, it has to be ensured that the stakeholders involved in the living lab, they share the same vision and the same aim and objectives of the living labs that is reflected in the different projects implemented in the living labs, and so in the different activities, the micro level, that are carried out in the different projects. And here are some examples on the some of our members and some of the living labs already active since let's say a long time in the agricultural rural level. So the Greenpoint Living Labs that are active in Slovenia, that are focusing on sustainable production, food waste reduction, and knowledge sharing within the with agriculturists and rural stakeholders. And here you can see who are the stakeholders that are constantly involved in the living labs, as of course the research institution, but also NGOs, local authorities, consumers, food processor, agricultural advisors, or local farmers. And also another example is the smart rural living labs that are based in Portugal, that are focusing on agriculture, agri-food, circular economy areas or startups. They are working to generate new methodologies and technologies to in some way support the rural territories and address their, let's say, challenges or weaknesses that they're facing, and to ensure sustainable rural development. And so these are some of the examples that you can also find on the website if you want to know more of other type of agricultural or rural living labs. And with this, I end my presentation. Thank you so much.
Thank you very much, Delinda, for this overview on how structured the processes are really important for successful living labs, but also going from a co-construction and co-creation. So next, I will ask Julie Menadi to take the floor. And Julie is an engineer and a head of DG Farms network at ACTA. And she will present today how demo farms are looked at in Codex. and as platform for digital innovation, and she will present the work from the handbook on demonstration of digital technologies. Julie, the floor is yours.
Thank you, Mavé. Let me know if my screen sharing is working, please.
Yes, it's working.
Okay, perfect. Thank you. Well, good morning, everyone. My name is Julie Menadi. I'm from ACTA in France. In Codex, we're involved managing all the demonstration activities of the project because they're a key part of assessing and demonstrating new technologies. So first of all, let's make something very clear. What is technically a demonstration? A demonstration is the act of showing in real conditions an innovation or a technology, a practice, or a system. It is a very important activity as in agricultural sector, farmers need to see concrete evidence to believe what we are sharing with them. And demonstrations are a very important moment to incentivize peer-to-peer learning. Having these kind of meetings really encourages discussions. And a demonstration usually has this same structure. So there's obviously the demonstration part where you showcase the technology, innovation, or practice. But then around it, you have other activities that are very important. So there needs to be facilitation to encourage discussions, to encourage also exchanges of knowledge, and then reflection between the participants around what has been demonstrated. Obviously, to make sure that the demonstration is in a whole dynamic, we need to have some reporting from this demonstration to move forward into even improve other demonstration or to go further in other events. In Codex, we have a bunch of different demonstration methods, and I'm going to go through them to explain to you why they are important and what is the differences between them. In Codex, we are working both on physical demonstration and on virtual demonstrations. When it comes to physical demonstrations, there's what we call the national visits. I think it's the most classic demonstration we might all know when you go to a farm to see a demonstration. But then we have the cross visits. The cross visits are physical demonstrations. The only difference is that you get to invite partners from other countries, other living labs. So now you reach a wider audience and you get to have more exchanges with other living labs, other experiences. So that's for the physical demonstrations. Then we have the virtual demonstrations, and these are new ways of demonstrations we are experimenting in Codex. So we have the Farminars. It's, as you can guess, the contraction between farm and webinar. The goal is to have a virtual meeting like the one we're having right now, and to showcase the technology with a lot of different formats. It can be videos, photos, sharing some opinions from experts, having roundtables, trying to have all the different tools to make this demonstration as immersive as possible. What is interesting with Farminars is that you reach an even wider audience because you can go cross-border. You can also reach people that won't necessarily move to a farm. And what is interesting, like we're doing today, we're recording this meeting. Farminars can be recorded too and then be available 24/7 afterwards. So that's a very interesting tool when you want to reach wider people and wider audiences to demonstrate new technologies. And then the final type of demonstration we are doing in Codex are virtual tours. So that's even a different type of demonstration because we are creating a demonstration that's accessible 24/7. We're creating a whole website with immersive content. You can see it as going through a video game. You can explore the farm. We have these 360 cameras that recreate the whole farm system, so you can really navigate through the farm and have access to different types of content around the farm, the technology. So these are really huge projects that we're creating in Codex and that are going to be soon available on the platform. So you get to see and explore at your own pace, at your own rhythm, whenever you want, these farms and to see what the Living Lab is working on. Why do we do demonstrations in Codex? We have two main goals in Codex when it comes to demonstration. The first one is to showcase the digital technologies for agriculture to the Living Lab stakeholders ecosystem. All our Living Labs have different new technologies they want to showcase, and they all have their own stakeholders. The goal is to have these activities in each Living Lab. By doing so, we want to gather empirical information on the digital technologies because the goal for us is then to be able to assess the costs and benefits of such technologies. So we are going to have these discussions with the participants on how they see the costs and benefits, and then later on in the project, we are going to analyze all those results to have a project level type of results. In Codex, we have 20 living labs, and I'm sure now with the presentation of Dolinda, you know exactly what a living lab is. They are present across 19 countries, and in total, we are going to have 40 physical demo events and 20 virtual demo events. That's very interesting because, well, it helps us to reach a lot of people and a lot of stakeholders, but also to try and play with different demonstration methods. And that's going to be one of the results of the project, is what are the best practices when it comes to demonstration. So in Codex, we develop the toolbox for demonstration, whether it is physical or virtual. So what are the key steps? There's the demonstrations, obviously. I could end my talk there, but it's not that easy. Actually, what is very important when it comes to demonstration is all the preparation part. So it is very important to set clear objectives and messages you want to share with your stakeholders. Also, the organization team. You can't rely only on the farmer hosting the event. You need to have facilitation, logistics experts. So you need at least 4 members in your team making sure it can go smoothly. And for example, if it's the farmer providing information, that he can truly focus on that and on the discussions with the participants. Then you have the target audience. As Dolinda shown, there's a lot of stakeholders around living labs, whether it's farmers, advisors, consumers, can be also policymakers, and so on. You need to know who you are targeting because the information they're coming to look for is going to be different regarding who they are. So really setting who their target audience is going to be key on what you show and what information is going to be important to them. And obviously the promotion of the event, the goal is to reach as many people as possible. So trying to promote the event early on is really a key step for success. When it comes to the demonstration, there's obviously showcasing the technology in itself, obviously, but around the demonstration, we also in Codex develop a list of learning and facilitation methods to build discussion around it. We also are there to make the best use of the host farm. So you'll see setting the scene of the living lab and the demo farm around the new technology really shows how it is included in a system, and that's really key to assess the new technology. And then obviously after the demonstration, we need to have this reflection with all the participants to evaluate the new technology and to report what has been exchanged and all the different feedback from the participants, and a follow-up, because it doesn't end at the demonstration. We have other demonstrations, we have the rest of the project, the rest of the living lab activity. So it's important to make the link between that and to ensure that the stakeholders are still included in all those activities. I only have 10 minutes now, so I can't go into much more detail, but I can just highly encourage you to go look at our handbook on demonstration when we go into detail for all these key steps and what we have done in Codex. I'm just going to zoom in on new ways of demonstrations who are working on Codex, and it has to do with the virtual demonstrations. What is it interesting to try this kind of demonstration? Well, as I said earlier on, it's important because it helps us reach even wider audiences, and we can go beyond the living labs borders, and that's very interesting also to create links with other living labs, for example, and to reach other countries. We have done so in Codex already, and we have really interesting discussions when, for example, they have a common sector but different production systems. We have very interesting discussions around new technologies. Accessibility is a key step also. We can reach out to people in remote regions, people overseas. We can also reach out to people with, let's say, mobility issues that can't really access those demonstrations usually. Such as on-farm demonstrations, we now have a ton of tools online to have facilitated discussions, whether it's chats, polls, whiteboards. We can really play with that and create these interesting discussions. And finally, it's making the content available 24/7. Anyone around the world can access this information. So finally, I'm going to share with you the lessons learned we had so far on the demonstration. So the Living Labs had over 20 demonstrations so far, and we gathered together to share our best practices, difficulties we might have to improve other demonstrations, but also to see how we can define our best practices. So this is not the final version. You're having a spoiler of our next deliverable, so lucky you. It is very important for the participants to have concrete examples and the real world impacts of new technologies. They really want to see it in action in the real conditions to make it make sense. When possible, Living Labs highly encourage participants to try the new technologies. So when they can test and experience directly the new technology, it really helps them, picture themselves using it later on and also see how it feels like, and really try to have this as immersive as possible. For example, we have an auto steering tractor. You can put the participants on the tractor and to see how it feels like, what are the different experiences around it. Also, participants need clear and quantitative data. I think we'll maybe talk about it later on, but we really need numbers to show what are the costs and benefits of these new technologies. And if we go back to the target audience, you can target this data to the audience you are having. And finally, since we are gathering so many people, we need to create the conditions for informal exchanges and peer-to-peer learning. What has been funny is that all the Living Labs had the same practice, and I think it's a good one to keep on. Good discussions always happen around food, so sharing a drink or food at the reflection moment really helps creating more and more discussions among participants. That's something they look for when they come to demonstrations. So I just wanted to share two main resources that I think are key when it comes to demonstration. So the first one is the handbook on demonstration. We just released our final version, and it goes around all the different guidelines and steps we created around physical and virtual demonstration in Codex. And then we have more demonstration events coming. We have all the virtual events and all the physical events. All the events are shared on the Codex website, so make sure to go check that out. You can get all the information for the upcoming events, and if you want to join us, feel free to register, and we'll be very happy to have you on our Living Labs. That's all on my side. Thank you very much, and obviously we can talk later on for the discussions.
Thank you very much, Julie, for this great overview and this great explanation on how the demo forms are working in Codex. And we will have, so now we will go into some more examples and practical examples of demonstrations from the field. So we're going to welcome two pilots and two demo forms. The first one will be from Vineta Gailite, who will present the Codex demo form on grassland management in Latvia, which focuses on drones. Vineta, the floor is yours.
Hi. Hello, I'm very happy to be here. Can you see my screen?
Yes, we can see it.
Perfect. I'm Vineta Gailite. I'm from Estonian University of Life Sciences, and basically I provide the communications in the Living Lab between the farmers, other actors, and the digital technology facilitators. You can see the RQ code here on my opening slide. You can go ahead and scan it with your phone. This is our virtual tour of the demo farm. Also, there will be a link in the chat, which you can save, and then you can take a look in your own time at our virtual digital technology demonstration in the farm, which is called Becca's Nature Farm. And I will just start with explaining who we are. So we are Estonian and Latvian Farmer Lab farmer-led living lab, and we explored drone technology, which is different drones with different sensors and also software use in grassland management. But we particularly concentrate on EU valuable semi-natural grassland conservation and restoration. So there is our, you can see our actors in the Living Lab, which are people who manage grasslands. Mainly these are livestock farmers, private landowners, also smaller farms, which are meadow restoration enthusiasts, and also state-owned land, which is managed by the livestock farmers, grazing or haymaking. These are nature conservation areas and landscape restoration areas engaged in various different projects. Then we have such actors as knowledge institutions. This is besides our Estonian Life Sciences University. These are other universities like University of Latvia and others. Then we have also public actors such as grassland specialists. These are farmer advisors, which helps farmers throughout the grassland conservation and restoration process. They come from Latvian Nature Conservation Agency and also Latvian Forest Agency. And there in the picture you can see us, our digital technology providing team, which is Drone Lab, and we do drone-based remote sensing. And we are from the chair of Environmental Protection and Landscape Management. And this is us working together with the farmer at Becke's Nature Farm. So we really make use of the demo events. We introduce farmers to the basics of drone-based remote sensing, which is, in simple words, that's how to map your grasslands or your farm infrastructure. These demo events are specifically, first round of demo events were specifically designed for the farmers who have mapped their own farmlands, or we have mapped farms for them, and we are trying to demonstrate how to make the geo package, which is in simple terms, this is digital maps made by different drones and different sensors mounted on the drone. Then secondly, we are helping farmers to become independent in the digital space and explore all different possibilities, what they can benefit from use of geographic information systems. This is where you can interact with your digital maps. And then thirdly, because the map is also a document, this facilitates them and gives farmers the agency to engage in discussion with the grassland specialists. These are public actors and knowledge institutions, and often this is discussions about subsidies and other management needs, what farmers are discussing between the grassland specialists, advisors, and other researchers who are working with the farmers. Then this is our future, because we future demo events. You can see that what the multi-layered geo package looks like. It's different types of digital maps. We create not just maps, but also semi-automated land cover maps, which is we train the algorithms to recognize specific species in the grasslands and help farmers to identify species which they need to remove or to facilitate this restoration, which means actually just increasing the biodiversity in the grasslands. So next round of demo events, we want to deep dive to help farmers understand this semi-automation and really explore what farmer needs what kind of maps and what kind of algorithms the farmer needs to help them to restore this biodiversity, and also help farmers who are trying to meet EU nature restoration goals. I think this is about it from me. Thank you so much, and check out our virtual demo tours. Thank you.
Thank you very much, Vineta. So for the last presentation for this first webinar on demo farms, we'll give the floor to Nikos Georgiadis, and he will share, as Vineta was doing, some lessons learned from the QuantiFarm pilots, where they're testing real-time digital applications in cotton crops. So Nikos, I will give you the floor if you can be brief before we move to the discussion.
Hello, can you hear me?
Yes.
Can you see my presentation? Great, thank you.
Yes.
So, we are test case partners in the QuantiFarm project. Our case is to try variable rate applications in all tractors using an add-on which is called Augmenta Field Analyzer. Let me first give you a quick introduction about this analyzer. It's actually a multispectral camera system which is uses different bands, the near infrared, the red edge, the red narrow, and also two RGB cameras. In addition, there are several other sensors like a light sensor, a top camera that can be used in order to create a vegetation index. It has minimum requirements in order to be installed on tractors, so it can be used in either on high-tech or even lower low-tech farmers. And this is what is interesting for the project, because all tech farmers, small farmers with smaller crates can use a system in order to operate with VRE applications. It just needs an isobus display and the implement to be connected with an isobus, and the isobus protocol is responsible for the whole communication between the system, the display of the tractor, and the implement. As you can see here, it's something that's quite easy. It just needs the ISO box or an Omnibox, depending on the specific type of the protocol. So it's something that is plug and play in 3-4 taps away from the start to start the operation. You just select the type of operation you want. You just give some information that has to do with the crop type and the maximum rate to be applied. This is the only input that needs from the farmer. And while it operates, you can see the graph that has to do with the vegetation index that is scanned ahead from the tractor. So it can support a field of view that it can be up to 42 meters. This field of view is divided into 20 subregions, and in every subregion, the vegetation index is calculated. It matches to the perfect state for each range, and applies the average of all these cases. The Augmenta index, it was just how we call it, because it's a vegetation index based on the principles of NDVI, but there are also some different factors added and calculated in order to reduce the noise that you get from the environment conditions. So a low index is a dead plant. Average, a medium index can be low biomass, and high index could be high biomass, just like NDVI. Here you can see some examples of what we see with, let's say, the eyes of the system. And currently it can support several different arable crops, from cereals to oilseed crops, small grains, or even beans and legumes. And in this case, we had the cotton crop. We used it in our test case with the farmers in 2 different regions in Greece, in central Greece and northern Greece. Both regions are standard regions where the cotton production is really high, really important for the local economy. And we used the nitrogen application, both spread and sprayed, the insecticides and plant growth regulators, especially insecticides, was something that was a beta version, and harvest stage. Concerning the nitrogen VRA, you see there is in every case there is an agronomic algorithm besides each operation. The difference of the nitrogen VRA is that it divides the regions in different potential areas. The rich potential one, the low one.
I'm sorry, we
and
cannot
the
see
high
your
one.
presentation anymore. I'm sorry for interruption, but there is something wrong.
Does anyone can see my presentation?
I can see the
I can see it.
presentation.
Me too. I can see it.
Probably should be
Yes.
your service
You can
then.
continue.
Thank you. And the main thing for that is to apply the proper rate, so not to over apply and have an economic cost or an increased environmental impact. Neither under apply and have some yield loss from the farmer. This is a really nice case. We recommend to apply the maximum rate in the high potential areas and reduce the rate to be applied in the the high potential areas. In this case, we see that the yield is still increased. So it's a signal for the plants to stop, invest their sugars to biomass and invest them in the reproductive parts of the plant that is going give us higher yield. Here you see the flat rate application, the standard application that all the farmers do, have differences in the yield. This is a good case that we had from the northern Greece application in nitrogen. As you can see here, we have the vegetation index, the application maps that have been applied in real time, and we got some savings in the fertilizer of 5%, which was a reduced cost of 9 euros per hectare. The same thing happened with the insecticides. In this case, it's a biomass-related algorithm. As you can see here, we had really good savings, almost 13%, which for each case, it was 1.5 euro per hectare, and that was only for one application. Same thing with plant growth regulators. I won't say long. Also good savings here, 5%. That means 1.25 euros per hectare. And harvest aid, in this case, it's something that we want to help the senescence of the application. As you can see here, we have much greener here, so we have applied more. Here we applied less, and the farmer achieved 10% of savings, that is 2 euros per hectare for each application. After that, everything can be all the data can be gathered from the farmer and gather all the data and create his own reports that we can help him in order to understand the results and have a better plan for the next cultivation period. Up to now, except for the savings, has been recorded a yield increase of up to almost 4%. The partners of ours, of Polimi, the Politecnico di Milano, from Quantifarm calculated the gas emissions via the reduction of nitrogen is minus 14%. And also we've seen that the quality characteristics and ground truth measurements that we got there was something that had no difference despite the savings that have been provided. That was for me. Thank you very much.
Thank you very much, Nikos, and thank you to all the speakers for the presentations. So now we'll open the floor for a Q&A and for discussion. So I will give the floor to my colleague Raquel Pastor, who is going to moderate your questions and your reflections.
Okay, thank you, Merveille, and thank you so much for this insightful presentation. Now we have this open discussion space. I think we have a few questions in the chat from Nikolaos. I think it's regarding about living labs, and the question is to Dolinda. Nikolaos, I don't know if you want to ask yourself your question. If you want, open your micro. I don't know if you are still here. Well, in that case, I can read. The question is, how can the small farmers... Yes.
Hello, can you hear me?
Yeah, perfect.
Yes, thank you very much. A small question about the incentives and for the small farmers. Just for the small farmers, how they can be persuaded to participate in Living Lab. We can understand that for bigger farmers or big farms, it could be much easier, but for small farmers, what are the solid incentives and in short term, because they are concerned about this, because okay, it's not easy for them to be a farmer and they have to invest time at least on this. Thank you very much.
Yes, I'm thinking about some of the examples also of our members that let's say they share with us their experiences also with small farmers. I'm thinking about some of the one living lab that we have in Serbia, who is working with small farmers, and so the benefits are multiple, because in some way, if you're asked to if you need to develop new technologies, then these new technologies can be useful for the small farmers, first of all. Then the products that the small farmers produce then have more, let's say, they have more certainty to be then put on the market. So there are several ways to facilitate their engagement in the living labs. In some cases, there is a strong participation of maybe some advisors or farmer association that can help the participation of the farmers in the living labs activities. And then, of course, there has to be a lot of also flexibility in the living lab management, in adapt to the farmer's schedule or timing, because we all know that there are some specific moments when there is less time for farmers to participate in other activities. And so this was some of the main, factor that help the farmers to participate in the activities. So the living labs, what they were telling us is that maybe they were organizing some activities on Sundays or maybe in the evening, because it was just easier for them, for the farmers to participate and not to steal time from their working time. Yeah.
Thank you, Dolinda. I think Vinita want to add information about this. Vinita,
Hi, I just wanted to say in our living lab, we mostly have small farmers, and just few examples why they participate and what's their benefit. Firstly, it's making sure that we provide some really useful digital solution for the farmers. So we tailor we really talk to the farmers what exactly they need from this, what we call remote sensing or drone technology. Then secondly, we actually we don't create any monetary value, but we actually give them these maps or aerial photographs, all the we are scientists, but we also give them all the digital data we create so they can interact. These can be just aerial photos, maps, and these also, as I said, these are just documents which they can use in the negotiations with their advisors. And then just this, I think for the small farmers is really useful, this co-creation process, because I think sometimes, at least here, small farmers are kind of not engaged in the industrial farming. So this co-creation process really helps them, and specifically in digitalization, because it's gives them advantage in their farming.
Thank you, Vineta. I don't know if anyone else want to add any reflection about this. We have 2 more questions in the chat and a few reflection of this. Carmen, I don't know if you want to ask yourself your question, because I think it includes a brief reflection of this topic. It's about efficiency, accessibility, transparency, proof service. Carmen, in that case, I can read that for you, but okay. I'm going to read the question in the chat. Digitalization of farms can be considered a good thing from several perspectives: increased efficiency, accessibility, transparency, improved service. However, there are also negative aspects that need to be taken into account, such as limited access. Not all farmers have access to the internet or are not familiar with technology, which can create a barrier to accessing service. Also technical issues, and need for training. The question is, how can these issues be resolved, and how can research institutes be involved to support farmers? Vineta, Dolinda, Julie, also Nick, if you want to participate. Yeah, Julie, please.
Yes, thank you. Well, first of all, thank you, Carmen, because yes, I totally agree with you. These are key issues that needs to be addressed. Outside of Codex, I also coordinate a network of experimental farms called DigiFam, and they are especially working on new technologies in our experimental farms. Some of them are part of the Living Lab and members of Codex. And what we think is interesting is that these experimental farms, when it comes to relationship with companies developing these new technologies, is that we can represent our farmers and their needs to the companies. They can come and test the solution on our farm. So the risk is not given directly to the farmers. We take that risk with the research institutes and technical institutes, so we can really try in real conditions those situations and help them improve them to really meet the needs of our farmers in our area. But then when it comes to the Living Lab, the demo farm, and the farmers, is that farmers see technologies in a farm that looks like their farm and also represents their reality. When you were talking, for example, about limited access to connectivity or things like that, we also recreate those conditions in our living labs, in our farms, when we test those solutions. So they can really rely to what we are showing. And then at demo farms, it's interesting because we can do demonstrations and share this knowledge, but oftentimes it's also a place where we host training, exchange information on how to use technologies. As Vineta said, they're really trying to explain to farmers how they can really use the technology in their farm. And that's something you can find on other farms. That's why I think living labs, demo farms, experimental farms have this key role of bridging between the needs of the farmers, their realities, and then the companies developing those solutions to really meet the need of the farmers and what could be created. So I think the Living Lab ecosystem with the research institutes, technical institute, and all these actors around farm are really what makes that useful and usable for the farmer. And that's why I think we need to still work on those Living Lab ecosystem, because it's really a place where we can make farmers meet and also go towards adoption of new technologies and technologies that make sense to them, if that's clear.
Thank you, Julie. Yeah, Dolinda, please.
Yeah, for sure, there can be, some challenges, but this is why it is essential to involve farmers and all the users since the beginning. You cannot involve them at the end and telling them, okay, this is what you have developed. You have to involve them from the beginning, and it is essential to have an iterative process where you receive feedback and you take this feedback and you try, you also, so this feedback can also be the challenges, and you try to address this challenges and this feedback in developing something that it is useful for them. So first understanding what is the need, and then engage them in the whole process in developing something that they actually need. So there is the interest for them to participate. Yeah.
Yeah, I see Carmen has the hand raised. Please, Carmen, and then we move to the last question and move to Mentimeter. Carmen, please, if you can.
Thank you for the presentation. Only I want to say that research institutes have the know-how, and we just need funds allocated to support farmers to develop.
Okay, thank you, Carmen. Last question is about, here is Joseph asked about, did you conduct cost-benefit or similar analysis in the project? Could you recommend us to other source of information on the financial sustainability of investment in digitalization, especially for small farms? And there are a lot of few questions in the chat, if you can answer them now. But for this, about the cost and benefits analysis.
So I was looking for the questions. So I think the main point is to understand, if I understand well, is to how to ensure the financial sustainability of the living labs. And so there's the main point is that, first of all, the living labs should not relate on one project only, but it is essential to think on the macro level that I explained before, to have a vision, an aim, and to develop a business model that can support this the continuation of the living labs also beyond the specific project funding. And this it depends on who are involved in the living labs, how the stakeholders can work together on this. And so a business model should be developed for this. And so either you with the support and trainings, or in some way how developing a business model that can be sustainable. This is the only way.
Maybe if I am allowed, maybe I can clarify my question. This is Josip Jurecek from Zagreb University. Actually, my question is related to how to demonstrate to the farmers when you talk to them about digitalization, about digital technology, smart precision agriculture. In many cases, very, very small farmers in not a very nice financial situation. They usually ask, okay, how much does it cost when I will get the money back, and how can I do it? How can I afford it? And then I am always struggling to find sources showing them. So this is a project that was done, and in that project they calculated how much it costs and what is the cost, and how much it will cost you. What would be the best technology you can introduce immediately? What is not what is not affordable to you right now? So what should you do, and how can you get it, and how much does it really cost in real life? Do you know any nice resources or publications or projects that were dealing with that issue, not about the project or the living lab financing, but how to, during demonstration, how to answer farmers' question? How much will it cost me?
Julie, please, and this then we move to the Mentimeter, and if we have time, then we can continue with this question. Julie?
Okay, I'll try to be quick this time. Well, thank you for the question. It's clear enough for me. So that also goes back to when you know your target audience and you know that it's going to be farmers, you need to provide data that they're interested in. That's exactly what you described, like how much is going to cost me, is it going to be effective, or is going to be the efficiency on my farm, this type of data. And that's something we notice in the demo farms in Codex, is that they provide such information when they know farmers are showing up, because that's what they're looking for. And on the project level in Codex, we also have a task working on the analysis of the economic costs and benefits of these new technologies for each living lab and their own technologies. So they are carrying an analysis of economic cost at different levels, the process level, the farm level. So they also address the transition cost, so going from no technology to this kind of technology in the living lab, so the cost of the investment and the effort, operation cost, and all the benefits. And then they also try to see at the system level, working more on the digital ecosystem and trying to see if there are any other effects of introducing these new technologies, economically speaking. And so these are results that we should, I'm not in this word package, so I'm reading at the same time, that should be released fairly soon. And I think we can maybe send you the link when that's available. We tried to do it for every living lab for their own situation and their own technology. So that's one kind of result that you might be interested in, is economic results. But then talking about other projects, maybe it's not really at project level. For example, the network of digital farms that I have in France, it's an ongoing process. Every time we have these technologies, we always have these discussions, and we always try to produce results that speak to farmers. So production references, for example, and really numbers and data they are looking for when they are going to consider buying this technology for their farm. And then I'm done. I'm done talking.
Thank you so much, Julie. Thank you all for your presentation and for being here. We are moving to a Mentimeter question. So, Merville, if you can share. Okay, you can scan this QR or join to menti.com, entering the code that appear on the screen, and then we can move in a minute. Okay, I have 16 people. Okay, let's wait for 30. Okay, we can move to the first question, I think. Yeah. You also joined using the code that appeared up in the screen, okay? For those who are not here. Which type of organization are you representing? This is a description question. Okay, we have scientific community, research and innovation networks, civil society, and others as much as. Okay. Next question is related to, in your view, what is needed to make a farm demonstration effective? This is an open question. You can include your response. Okay, we have a few responses. We have co-construction, a good communication towards farmers, interaction, also related with the last one, clear objectives, engagement with the farmers at all stages, good preparation, hands-on demonstrations and data to show the impact of the technology, target farmers' needs, to discuss with the stakeholders how to carry it out. Okay, most of them are, as Delinda said, users in the centers as actors, not factors. I think it could be summarize most of these responses. Concrete information about cost, good preparation, catchy subtopics for farmers with timing, knowledge, product or service validation with impact evidence that allows it to scale to work in farms. Okay, interesting. Clear objectives again, time for reflections, involvement of all important actors, first-line farmer again, advisors and researchers. On top of that, a good promotion is needed as well. Okay, interesting. I think we have a lot of responses here. Maybe we can move to the next one. This one is as a description form. From your perspective, what can motivate farmers to try new digital technologies? We have different options. I think you can choose two of them. No, you can choose once only. Okay, for the moment, clear economic benefits. It's the most important motivation for farmers to train new digital technologies and also transfer knowledge on how peer-to-peer learning from other farmers. These are the two most important or most motivate inputs for farmers. Okay, what do you see as the biggest barrier to digitalization in agriculture today? Also, you can choose one of these options. Okay, in this case, this can be clear that complexity and lack of training is one of the biggest barriers to digitalization in agriculture today. It's clear with different points. Okay, the next one is regarding what is most need to scale up demonstration activities across Europe. Again, one choice. Okay, now we have more funding and support to better collaboration across regions and stronger farmer networks. these are the three elements needed to scale up demonstration activities in Europe. And the final question is, in one word, how would you describe the role of demonstration for the future of digital farming? Okay, we have a big one is essential. Demonstrations are essential and also important. It offers practical guidance, critical, open science, multiplier of knowledge, education, determinate awareness. Okay, you can include more words if you need. And for me, I think we have finished the Mentimeter. Thank you so much for participating. And Merveil, thank you so much.
Thank you so much, Raquel, for this, and everyone for participating in the discussion. So this discussion was quite interesting to show how demo farms can give practical insights into how digitalization works in the field.